Here is number 31 in chapter 12. Here's the question. The design for a new bolted flange coupling calls for 6 steel bolts, 3 located on a 6-inch bolt circle and 3 on a 4-inch bolt circle. Okay, so this is what that would look like. Here's our 6-inch bolt circle, and what we're going to care about in a minute is the radius from the middle, which is actually going to be 3 inches if the circle has a diameter of 6. And it also said there was 3 bolts on the circle, and there's also 3 bolts on a 4-inch bolt circle, so that one would have a radius of 2 inches, and here's the 3 more bolts on it. Continuing with the question. If the coupling is to transmit 105 horsepower at 1200 RPM and the allowable shear stress in the bolts is 9,750 psi, find to the nearest 1/16 of an inch the required bolt diameter. So these bolts are going to apply forces to rotate this thing, and we know that the outer bolts are going to be applying a little more force than the inner bolts, which is described mathematically in equation 1216 in your book, which is FB1 over its distance from the center of rotation equals force from bolt 2 over its distance from the center of rotation. So let's define our bolt 1s and bolt 2s here. I'm going to say that the outer ones farthest from the center are going to be bolt 1, and the ones closer to the center are going to be bolt 2. Now altogether, all 6 of these bolts are providing enough force to create a total torque to provide 105 horsepower. So let's just start by figuring out how much torque all these 6 bolts are needing to apply. And we can find that torque from the equation for horsepower. And we can just solve this equation for torque T. Here P was the 105 horsepower, and N is the revolutions per minute, which was given as 1200. So the total torque provided is 5,513 pound-inches. The torque from any one bolt is the force it's applying times its moment arm. Remember, the moment arm is the distance from the center. So for bolt 1, the force it applies times the moment arm is R1, that's the torque it applies, F times R. But there's more than one of these bolts. We know there's 3, but for now let's call this N, so we can apply this equation generally in other circumstances also. And then there's also n number of our second kind of bolts, which apply a slightly lower force, FB2, at a slightly shorter distance from the center. So the moment arm for those bolts is R2, and the force they apply is FB2. This force times the moment arm, again, is the torque. So we just came up with an equation for our total torque, T. And it has 2 unknowns in it, FB1 and FB2. If we're going to be able to solve for FB1 and FB2, we need a second equation that relates those 2 variables. But we already had one of those. The one that tells us that the longer the moment arm, the higher the force applied. So let's solve this one for FB2. so that we can insert this definition of FB2 into our other equation. Let's go back to our equation on the left and write it out with all we know now. So that N1 is just the number of bolts at distance R1 from the center, which was 3. FB1 we still don't know, so that'll be our unknown. We do know its distance from the center, which was 3 inches. And then the next part of this equation is those 3 inner bolts that apply a force less than the force of the outer bolts. And we just defined FB2 in terms of FB1. Actually, let's go back to the right and define it a little better. Let's put on our values for R2 and R1. R2 was 2 inches, R1 was 3 inches. So we can say FB2 equals 2/3 of FB1, or 0.67 FB1. So instead of writing FB2 up here, I'm going to write 0.67 FB1. And then R2 is 2 inches. And we can simplify this equation a little. 3 times 3 FB1 is 9 FB1. 3 times 2/3 times 2 FB1 was it? 3 times 2/3 times 2 is 4 FB1s. And we can put in a value for the torque that we found here. And add up our FB1s and get a value for that force. Now is the point at which we should think back to what this problem is actually asking us. It's asking us the required bolt diameter. So we have to figure out the maximum shear stress on these bolts from the pounds of force that we just found. And it's really the FB1 force that we're concerned about, because it's the higher force. We know that it's like 50% higher than the force on the inner bolts. So it's really the shear stress in these outer bolts that's going to be higher. So we have to figure out the shear stress that's caused by this 424 pounds of force in the outer bolts. So on our way to finding diameter, let's find the area first, because then we can use our simple equation for shear stress. Shear stress equals shear force per area. And that force that we found is the shear force. And solving for area, we get A equals shear force over shear stress. So that's our V, and the allowable stress was given in the question. It's 9,700 psi, which is pounds per square inch. So now we have an area, and we know that the area is related to the diameter by that equation. So now we can just solve this equation for D. I've solved for D squared right now, so we just take the square root of both sides. And this is just less than about 1/4 of an inch. So we would need at least have 1/4 inch bolts, which is 4/16 of an inch diameter.
Made with Doodlecast Pro.